In this example, we're going to do the same thing as we did before, except now the body of our loop is going to increment CT by 2 instead of incrementing by 1. So with this change, see if you can figure out what the output is going to be. So CT is initially 0, that part hasn't changed, and we go into the loop right away, so we'll increment CT by 2. This means when we do our first condition check, we're checking to see if 2 is less than or equal to 3. Well, this is true, 2 is less than or equal to 3, so now we're going to go back into the loop, and here we're going to increment 2 by 2, so that's going to give us 4. So notice that we're going to keep repeating this as long as CT is less than or equal to 3, but the second time we go into the body, CT becomes 4. So when that happens, we find that 4 is not less than or equal to 3. That's false, so we're going to exit the loop, and our output is going to end up being 4. Here's another example of a post-test do-while loop. So take a look at this and see if you can figure out what the output's going to be. In this case, CT is initially 0 again. We're going to go into the loop, and we'll increment CT by 2. Nothing really different from what we've seen before. So the first time we check the condition, we have that 2 equals 2. Well, that means 2 is not less than 2, so that's false. So we're not going to go back into the loop. Therefore, the output in this case is going to be 2. Here we have another example. The only difference between this and the last example is our condition is checking if CT is less than or equal to 100. So let's follow this code and try it out and see if you can tell me what this is going to end up being. So once again, we have CT initially 0. We'll go into the loop because this is a post-test loop, and we'll increment CT by 2. So the first time we do this check, or check our condition, we're going to see that 2 is less than or equal to 100. That is true. So we're going to go back into the loop. And we're going to keep repeating this as long as CT is less than or equal to 100. So notice that we're just incrementing CT by 2. So we'll have 2, 4, 6, 8, 10, 12, and so forth. Eventually what's going to happen is CT will get to 100. 100 is less than or equal to 100. That part is true. We'll go back into the body of our loop, and CT will become 102. When this happens, that is when we'll exit the loop because 102 is not less than or equal to 100. This means our output is going to be 102. Here's an example where we use a for next loop. So take a look at what's going on here and see if you can tell me what the output would be. In this case, CT is still 0. That hasn't changed. And we have K initially 1. So what's going to happen is we'll go into the loop and we'll increment CT by 2. So that really isn't different from what we've seen before. And what we'll do is we'll keep incrementing K and repeating this loop as long as K is between 1 and 5. So K is initially 1, we'll increment CT by 2. And then we'll increment K by 1, we'll repeat the step, and we'll keep going as long as K goes up to and including 5. This means when K becomes 6, we're going to exit the loop. So then the question is, how many times do we add 2 to CT? Well, we start when it's 1, 2, 3, 4, and 5. I counted 5 times if my math is correct, which I think it's right. So we find that we're going to add 2 to CT 5 times. This means the output is 10. Now there is one other thing I want to mention in this particular example. If you look at the code, you'll notice that I did not include next K at the end of the for loop. So there's nothing right here. In our previous examples, we had the K there to say that we're going to increment K by 1, or whatever our step amount is. I want to point out that this is actually an optional thing. We don't have to put the K at the end. We did it before just to show you that it is an option, and it's probably a good idea to include it, but it's not required for it to work. So this is intentional, it's not a typo. Here's another example of the for next loop. So we see that the body of the loop is a little different than what we've done before. So I'm going to ask you again, try out this code and see if you can tell me what's going to get stored in the text of our label. So once again, CT is initially 0 and K is initially 1. So we're going to go into the loop right away and increment CT by K. Not 2, not 1, but whatever the value of k is at that time, and we will keep repeating this and incrementing k as long as k is between 1 and 5. So as we've seen from before, we're going to stop when k becomes 6. So the question is, what exactly are we adding at each iteration? Well, the first iteration of the loop, we're going to add 1 to CT. The next iteration, we're going to add 2, and then 3, and then 4, and then 5. So we're adding 1, 2, 3, 4, 5 to CT. This means our output is going to be 15. We'll do one more example. So we're still using a for next loop, and we see that we're changing the body of the loop a little bit. We're even changing the range of the value of k. So with those changes, take a look at this and see if you can determine what our output is going to be. So once again, CT is initially 0, and k will be initially 1. And what we're going to do now is we're going to go into the loop, and we're going to increment CT by k squared instead of just k or 2. And we'll keep repeating this as long as k is between 1 and 3. This means that when k becomes 4, we know we're done with the for loop and we would exit. So the question, though, is what exactly are we adding to CT? Well, when k is 1, k squared is 1. When k is 2, k squared is 4. And when k is 3, k squared is 9. This means we're going to add 1, 4, and 9 to CT. Therefore, our output is going to be 14.